Okay, on 11 and 14, we need to simplify these rational expressions that have complex numbers in the denominator. So the goal is to get rid of the imaginary part in the denominator, and the only way we can do that is to multiply by the conjugate of the denominator on both the numerator and the denominator of this fraction. The conjugate of 3 plus 7i is 3 minus 7i. So multiplying these two using the distributive property gives us 6 minus 14i plus 21i minus 49i squared. Similarly, on the denominator, we're multiplying conjugates, so we should expect the middle terms to cancel out. So 9 minus 21i plus 21i minus 49i squared. So we can see here that these middle terms will end up canceling. So let's continue to simplify. So we have 6 positive 7i. Negative 49 times I squared ends up equaling positive 49. And then in the denominator, middle terms cancel out, so that gives us 9. Just like we just did up in the numerator, negative 49i squared is equal to positive 49. So that would give us a final answer of 7i plus 55 over 58. And it is customary to write the complex number as real part and then imaginary part, so I'm going to change that. And that would be our final answer. On number 14, we have the expression negative 10 over 4i. To get rid of the imaginary part in the denominator, we need to multiply by its conjugate on top and bottom. So the conjugate of positive 4i is negative 4i. And let's see what we get when we multiply by that. So negative 10 times negative 4i is positive 40i. 4i times negative 4i is negative 16i squared. We would reduce this, simplify just like we would simplify any other rational expression. So 40 over 16 simplifies to 5 over 2. And I'm going to put a negative there. The I, we cannot simplify any further, but the I squared, we can simplify to negative 1. And the denominator then becomes positive 2. So our final answer is 5i over 2, and we do not have an imaginary portion in the denominator.